This video is to allow you to correct your homework for section 1.2.3. Again, before we start that, I want to go through the methods and meanings information. So the numbers 1, 2, 3, 4, 5, 6, and so on are called natural numbers or counting numbers. A natural number is even if it's divisible by 2 without a remainder, otherwise it's odd. Whole numbers include those same natural numbers but also include 0. If one natural number divides another without a remainder, we call that first one a factor of the second. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12, because 12 will divide by all those numbers without a remainder. If a number has exactly two factors, 1 and itself, it's called a prime number. If a number has more than two factors, it's called a composite number. The number 1 has only one factor, which is itself, so it's not considered prime nor composite. And then they give you a nice list of all the prime numbers less than 40, so you may want to even put those into your toolkit or notebook. Be a helpful list to have. So starting with correcting our homework 1.2.3, Harry had a pile of 48 pennies. He organized them into a rectangular array. It had exactly 4 rows with 12 pennies in each row. They want you to draw diagrams to represent at least 2 other rectangular arrays he could use, and do you think there's more? So some of the ones that I have are, we have a 1 by 48, so you could have 48 pennies all in a row. And of course, if you change the order of that, a 48 by 1, it would be the same array, the same, look other than just turned. 2 by 24 would be 2 rows of 24 pennies each. 3 by 16 would be 3 rows of 16 pennies each. 6 by 8 would be 6 rows of 8 pennies each. And of course, the one that we don't have to put again because they've already addressed it is 4 by 12. And then for this one, they want you to arrange them into a complete rectangular array and then into a different rectangular array where there's a remainder of 1, so there's 1 extra penny, and then write an expression for each arrangement. So if we're looking at 10 pennies, we could do a 2 by 5, which would be written as an expression of just 2 times 5. We could also have gone with 10 by 1. That would have worked too. And the one with the extra penny I did was a 3 by 3 plus 1. So again, this is my drawing, and then this is my expression. For 15 pennies, I went with a 3 by 5. Again, you could also have gone with a 15 by 1. And then here I went with a 2 by 7 plus 1. For 25 pennies, you could go with a 5 by 5. And for the extra one, I went with a 4 by 6 plus 1. But again, you could have gone with like an 8 by 3 plus 1 as well. How many pennies are represented by each of these expressions? So this would be 3 extra pennies plus 4 groups of 5. Well, 4 groups of 5 is 20, plus 3 would be 23. Here we'd have 4 groups of 3, which is 12, plus 7, so 19. Here we'd have 2 groups of 3, which is 6, plus 5, plus 4 groups of 2, which is 8. So 6 plus 5 plus 8. Make sure you're showing some work here as well, not just the answer. And that is also going to be 19. So for these, I should see how you got those answers. Here they want you to use whole numbers, fractions, and decimals and write at least 8 addition equations that have a sum of 10. And of course, there's a, almost infinite amount. So the ones I started with were 6 plus 4 would equal 10. 1 and 5/10 plus 8 and 5/10 would equal 10. 7 and 1/3 plus 2 and 2/3 equals 10. They wanted 8 of them, so you could come up with lots of other options as well. Here, we are going to put in the correct inequality sign, less than or greater than. So again, my suggestion on this is to add a non-essential 0 so they have the same number of decimal places. So this would now be 5 and 207 thousandths compared to 5 and 270 thousandths. So that would, of course, be less than. Here, if I add a non-essential 0, I'm comparing 3 and 6 thousandths to 3 and 60 thousandths. So that's also, that's also less than. And here I would have 2 and 408 thousandths compared to 2 and 400 thousandths, which is greater than. Now they want me to go to part B and round it to the nearest tenth. So if I have 3 and 6 thousandths, the tenth place is here. To the right of that is a 0. So when I round, I'm going to keep the 3 as it is. The indicator number, which is the 0, tells me to round down, which means keep the 0 as it is. And then once the indicator number has done its job, it and everything behind it can either become zeros, or if they're behind a decimal point, they can drop off. So I would just get 3 and 0 tenths. For this one, which was 3 and 60, well, 3 and 600 before I added the 0. The tenths place is here. To the right of that is a 6. That's my indicator number. So again, I'm going to keep the 3 as it is. The indicator number tells me to round the 0 up to a 1. And then the indicator number has done its job, so it and everything behind it becomes zeros, or since it's behind a decimal point, it can drop off.